let's review ways to cut steel project costs in the area of decking design. We have made the point that increasing support member spacing not only saves steel, but also saves on piece count. A smaller piece count means less fabrication and erection time, and cost savings are compounded. When it comes to decking, a common practice is to specify the gauge as minimum. This can result in the use of a thicker gauge than is required. Always specify the gauge and finish along with deck types. This will generate more accurate quotes and eliminate the possibility of coil inventory problems at fabrication time. One way to reduce deck costs on large projects is to specify a special thickness instead of a standard gauge. A deck project in Kentucky called for over 6,000 squares of B deck, painted 22 gauge, totaling 488 tons. By switching to 23 gauge deck, the project experienced an 8% reduction in decking costs and a 2% overall reduction in the joist and deck package. When determining deck gauge, be aware of framing layouts that result in single or double span conditions. These conditions are due to sheet length or weight, deck openings, roof slopes, and columns that continue above deck. In the illustration, the joist girders are sloped as indicated by the bearing elevations on the bay. This requires a two-span condition in each bay. Such conditions should be considered when determining deck gauge. Shored deck construction is slower and more costly than unshored construction. To avoid this, the engineer of record needs to specify the deck type, gauge, and span conditions for unshored construction. And when shoring is required, notations need to be made on the contract drawings to alert all those affected. Proper deck finish is critical for overall performance. ANSI requirements are: galvanizing must conform to ASTM standards. When phosphatized and painted undersides are required, this must be done according to ANSI. Consider the environment of the structure. And do you really need G90? Deck accessories is another area for cost prevention. First, clearly identify each accessory. When not identified, they can all look similar. Identifying each accessory assures that all are accounted for. When an accessory is missing at a job site, this adds to erection management time and project cost. Also, try to specify standard deck accessories. Non-standard accessories will almost always add cost to a project. Engineers should show the strong position placement of shear stud to be placed on the contract drawing. This gives the composite slab a higher strength without having to add time, material, and aggravation. This practice needs to be recognized and adapted in the field. Of course, cost-accountable steel project design often begins with meeting the architectural goal. To support new architectural ideas and related roofline shapes, the use of special profile joists has grown. The specifications for these types of joists have been vastly expanded in the recent years. So it is now much more practical for an engineer to achieve some of the more imaginative architectural goals using steel joists. In every case, we start with the architect's vision, but it is up to the engineering profession to make these visions practical and cost-effective. By involving joist engineering early in the design process, you can quickly evaluate a range of cost-effective ways to achieve your architectural goals. Our investments in new cord rolling and rigging systems have expanded the possibilities of special joist production. This includes special accents and other structural treatments. By taking the project owner or developer's point of view, we can better understand the future of total project cost accountability. Building information modeling has come about directly in response to the need for total project cost accountability. We have learned several lessons about BIM. First, BIM is a team approach, and BIM works best when joist and deck design occurs early in the project. The steel joist BIM model and all other models flow into the master BIM model. Note the dotted line between the structural and joist models. These models are submitted together for the master model. Digital steel joist design is facilitated by a digital design component. The component enables BIM-based collaboration at every phase, starting with initial generic joist placement by the detailer, then sharing initial generic joist detailing information, and then the creation of the final 3D model for discussion and refinement of the plan. The BIM joist design component may be an add-on to the software provided by structural design software companies. Using the IFC format, BIM joist models can be exchanged with anyone on the project, regardless what software they are using. IFC stands for Industry Foundation Classes, established by the Building Smart organization. Here is how 3D digital design works in the steel joist environment. Conventional 2D design packages will generically represent joists in a drawing. To give these generic shapes actual dimensions, the joist supplier uses a design software component or plugin compatible with the 3D structural engineering software. So right away, you can see what is going on in the plan. You can see that we have a clash here with a mechanical run. Here's another look. By quickly changing dimensions, you can avoid the conflict and immediately verify the correction. BIM-based design projects are especially effective from the owner's point of view. The entire structural package, including joists, was modeled in 3D BIM, here using the Autodesk Revit platform. The timeline for shop drawings was reduced from 10 weeks to 3.5 weeks. Another goal of the BIM project was to better utilize the MEP space around the steel joists in the stores. During the digital design phase of the joists on this BIM project, many cost-saving opportunities were revealed. For example, the 3D model showed that a stabilizer was not planned for this joist girder. So the engineer designed a stabilizer hanger for the bottom cord extension, preventing a field erection problem. The reinforcement for this door framing, including bolting details, were clearly engineered in the model. The model also showed the RTDR framing, the mechanical support, by showing exact positioning. The 3D model enabled the structural detailer to coordinate with the steel joist detailer to extend the bottom cords of these double joists for added reinforcement. Design and connections for a satellite receiver support were clearly communicated. Roof drain positioning and support considerations are clearly aided by the as-built joists in the digital model. Even stairwell reinforcement was improved upon. When the plan was pulled into the 3D environment, the joists were used for reinforcement at the top. The design was correctly expressed on the bid documents for the structural steel and concrete package. So the design could be bid on as an already coordinated first competitive cost. With the use of BIM, a project can move from concept to reality much more efficiently and cost-effectively. Owner point of view will increasingly drive cost accountability on a project. As more owners, developers, and construction managers become informed about new and better methods of project delivery, they will insist on them.